you can program FPGAs on the Macintosh. And today I'm going to show you two different ways to do it. So when I first did my NAND To Tetris course a couple of years ago, you get into digital logic design. And at some point you say, well, doing this in simulator is fine, but I'd really like to put this on actual hardware, which makes you reach for an FPGA, a field programmable gate array. Now, my major work machine is a Mac. I have a Windows box, I use it for games, I have access to Linux machines, but I wanted to do this FPGA work on my Mac. So I went online, as one does, and I said, can one program an FPGA on a Mac? And I got a chorus answer of, no, Macs are stupid, why don't you just buy a Windows box, why don't you just use Linux? This is a terrible answer. If you're Xilinx or Altera, you're justified in not wanting to support another platform. Supporting a platform is expensive. Maybe there aren't enough Mac users. If you're an FPGA hobbyist and someone says to you, I want to do something with hardware, I want to do a cool hack, your answer should be, yeah, that's cool. Let's figure out how to do it, not go buy whatever the supported thing is. So that answer really kind of irritated me. And for a while now, I've been trying to figure out how can I program an FPGA from my operating system of choice without using an emulator, without using parallels. And thanks to the work of a number of people in the open source community, now I can do it. Now, because we live in the real world, we do still have some limitations on us. And the FPGAs that at this point I know how to program on the Mac are things like this that use the Lattice Semiconductor ICE40 chipset. This is a NAND Go board, costs about $70, and it's available from nanland.com. It's created by Russell Merrick, who has a fantastic series of YouTube videos and also books and instructional materials. And I really love all the stuff he does, and you should take a look, definitely. So let's jump in with our first method of programming an FPGA on a Mac. And this is IceStudio. It is a graphical shell to program an FPGA. So there's a few limitations here. We're not going to be using straight Verilog or VHDL. We will get to that later. But it's got a lot of convenience features. You can get your PCFs and pinouts for your boards, your data sheets, and everything. We're just going to make, I think right now, baby's very simplest possible circuit, just to show that this works. So we're going to go here to basic, and we're going to drop an input. All right, we're going to take our port name from the pin. Okay. And you can see these are all of the ports on the board. Let's take switch 3, just at random. And let's drop an output. We'll give this one a name. I should have named the other one, really. We'll call this LED 4. And let's just, I need to actually select which port this LED goes to. Let's go ahead and come over here to the left. You can see this drawer pops out. This little Lego block is going to be where our components are. Let's grab some logic and let's grab an OR gate. Drop that there. And let's put one more switch in. We're going to wire these up. Very simple, just like you're using Logisim or Digital or something like that. And now we're going to go and click the build button. This build will be very fast. It's done. Let me hold up the board here. Our upload is done. I don't know actually which of these is switch 2 and which is switch 3. Does not light up. Does light up. Does not light up. Does light up. Now, IceStudio is pretty darn cool, but suppose you just want to write your own Verilog and your own VHDL, and you don't really cotton to these fancy GUIs. You just want to fire up Emacs and get some work done. Well, you can do that too. There is a workflow using open source command line tools that will program your ICE40 based FPGA on your Mac without emulation just fine. Let's take a look at it. Now, before I go into this, I want to give credit where credit is due. This is not a workflow that I came up with. This is building on the shoulders of probably hundreds of open source developers. And in particular, I basically followed a cookbook created by Nish Tahir. He blogs at nishtahir.com. He's on Mastodon and Blue Sky. And he has a page entitled, and I'm reading here, Mostly Free FPGA Development Workflow for macOS. Nish, thank you very, very much. And I'm going to put a link to your blog here, and I encourage anyone who wants the details about this, if I go too quickly through it, to look at that page. He walks you through it one step at a time. All right, you can see I have some very simple Verilog here that says if switch 1 and switch 2 are pressed, illuminate all the lights, essentially. Connect the output of an AND gate of these two switches to all 4 of our LED outputs. So let's switch over to our shell. All right, so let's just go through it a step at a time, even though, as I said, you would more likely have a make file to do all this for you in one fell swoop. Nish gives an example on his blog of just such a make file. We've got our .v file. We're going to, I'm missing a quote there. We're going to synthesize that .v file. We get a JSON file as output. We're going to take that JSON file and we're going to place and route. We're going to pack it into a lovely little binary using IcePack. And then we're actually going to program the FPGA. And we're done. Are we sure we're done? I have not touched this since the last example. So I believe I have to press 1 and 2, which are the top 2 ones here. Oh, I got the numbers wrong. There we go. All 4 lights lit. Our program works. So that's it. We're not doing any complicated circuit design today. I just wanted to show you this is possible. You can have a Macintosh. You could not be using Parallels or VMware, and you can write Verilog code and burn it to your FPGA. And you should. And in a just world, I would be able to use my Xilinx board on Mac as well. So hopefully someone from Xilinx, if you're watching, we exist. We're out here. Most developers I know, even those developing for other platforms, have a Mac in their personal life because it's a great machine. So please port your official tools. We'll use them. Thank you. Well, thank you for letting me take you on this little adventure. You're watching Tea Leaves Programming. Today we are programming like it's 1979, except I don't think FPGAs existed in 1979. Did they? Now I have to go look that up. First commercially viable field programmable gate array was 1985. So today we're programming like it's 1985. Thanks for watching.